Hi guys! Short circuit currents in household electrical networks typically go up to 1000 amps. That's why in some tests I want to run high currents through cables and circuit breakers. I know that my test setup can continuously supply around 250 amps. But how will it behave at significantly higher currents? I haven't tested that yet. Will the regulator and the protection of the setup hold up? Today's test will be quite interesting and exciting. I've connected a 16mm² wire to the current output number 1, and I'll gradually increase the current flowing through it. At the same time, I want to test the circuit breaker. I like Noark 63+ MCB with the Type D tripping curve. I chose it because it should be able to handle 500 amps for at least a few seconds. It should be able to handle even more, and I'm going to test that. According to the graph, at 10 times the rated current, that is 630 amps, it shouldn't trip for 1 to 5 seconds. First, I turn on the setup. And switch it to Super Mode. In this mode, fine adjustment is disabled, but higher currents can be supplied. I also decided to monitor the wire temperature using a thermal imager. Turning on the breaker, flipping the toggle, and setting twice the rated current. 63 times 2 equals 126 amps. Let's wait. So, we have the first point. Now I'll continue increasing the current in multiples of 63 amps. 63 times 3 equals 189 amps. No problem here. 4 times 63 is 252 amps. Good. I see that the breaker is hot and trips too quickly. The emitter and current clamps don't have time to measure the current. Luckily, the clamps have an inrush mode. This will help me set the current. Five times 63 is 315 amps. Next, 6 times. 6 times is 378 amps. Th 378 amps. Seven times equals 441 amps. Eight times is 504 amps. Okay, we supply 500 amps. Now I want 9 times 63 and it equals 567 amps. And the 10-volt current is 630 amps. Good result. Stop the test. I plotted the points on the graph with the curve, but I see that only the first and second points fall within the tripping zone. The reason is that I repeated the test immediately after tripping. The circuit breaker was hot, so it tripped faster. The thermal imager shows that it takes about 25 minutes to cool down. Now I'll repeat the test with cooling intervals. I've done all the tests. Here is the new graph. I'm really satisfied. The circuit breaker is working precisely, and it will be possible to supply large currents in the next tests. Thanks for watching. Write your comments. See you soon.